Okay, so I suppose if we just start with the sort of high level picture, there's a lot of electrification going on, and I guess that's sort of driven by the focus on sustainability, and therefore advanced power semiconductor devices are coming into focus quite sharply. I guess they've got an important role to play here, and within that, I think it's fair to say that silicon carbide MOSFETs 1200 volt, and I think the move towards 800 as well. If you can put that in perspective, is like how and why silicon carbide in this context is becoming so important, I suppose.
Yes, indeed. So in these silicon carbide devices, as you say, they play a very important role in this fast-growing market. I would say mainly driven by electrification, but also renewable energy, energy-efficient industrial systems as well. So from a market point of view, Yole Group forecasts the silicon carbide market to exceed $10 billion by the end of the decade. So yes, I would say it's a major market share for these advanced semiconductors. And of course, this is due thanks to their performances, their merits so the merits offered by silicon carbide devices mainly when integrated in such systems for this type of application.
Okay, and as a result of this, I guess, interest in silicon carbide MOSFETs in particular, Yole Group, you are focusing in this area and have produced a couple of reports, and I'll just read them out. So you've got silicon carbide MOSFET Discretes Performance Comparison Analysis 2024 Volume 1, which I guess suggests there might be more in the future, and similarly silicon carbide modules Performance Analysis 2024 Volume 1. So I guess it'd just be good to understand the background to those and what they're designed to achieve, if we can start with that.
Yeah, so indeed, so at Yole Group, we created this new range of products concerning the performance analysis of power silicon carbide discretes and power modules for different reasons. So first, we saw that, of course, the power electronics industry has seen a very important and growing interest for silicon carbide MOSFETs, as I said, due to their performance advantages. So on the other side, we identified somehow, I would say, a gap in the availability of reliable and third-party analysis that includes this performance data and to have this comprehensive, I would say, comparison under especially similar test conditions. So this is, I would say, the main lack of information that somehow can be challenging for some engineers and decision makers that are involved in these subjects. So we have developed this, I would say, framework to benchmark the performance of these devices to answer to this target.
Okay, and as I said, both of them are entitled Volume 1. So just before we go on, that suggests, I say, there's going to be further. Is there a regular? You're going to do these regularly every, I don't know, 6 months, annually? Is there a plan as to how often or will you do them just as and when more devices come out? Therefore, they need to be, evaluated, I suppose.
Yes. So indeed, so we have launched the silicon carbide discrete performance comparison Volume 1 last year, and now we'll be launching very soon. I would say in Q1, end of Q1 maximum, the Volume 2 of the report that will be including like more players. So in Volume 2, we will be including major players from silicon carbide industry like onsemi, Toshiba, Microchip, Navitas, and also SemiQ. So this will be more on the Volume 2. We have launched also Volume 1, as you said, from the power module. So we have started with the semiconductor for silicon carbide power module last year. And yes, we are intending to have other power modules, I would say leading edge power modules, analyzed later for the power module side of it.
Okay. Okay, and before we drill down into each of the reports a bit more, I guess again, just a bit of scene setting. The main application, I think you already mentioned renewable energy, but I guess is it fair to say that electric vehicles, electric transport is the primary driver when it comes to silicon carbide MOSFETs? Is that their sort of sweet spot at the moment?
So yes, I think so. Electric vehicle is very important market. Also, we have seen growing, I would say, integration of such type of devices for battery electric vehicles. So I would say these are very interesting markets for such type of devices.
Okay, and then if we can look at the reports in turn, I guess. So the first one was, just to repeat, is silicon carbide MOSFET discrete performance comparison analysis. And I think the high level idea at least, is to outline the performance benefits and any limitations. But that's a very simple. I know there are, I've seen the report, so there's quite a lot of complex information there. So I don't know how detailed you want to go, but please give us more information as to what you've actually carried out within the reports.
Indeed. So I would say basically our analyses are providing somehow benchmarks, I would say, and very valuable benchmark to the engineers that can rely on when they try to select the ideal components for their systems for their application, especially for the most demanding ones. So one of the advantages of our products is that beyond the performance test, of course, that we are performing, we are going also towards the physical analysis that we are conducting in our internal lab that are showing the different physical parameters and physical metrics of the silicon carbide devices. And also, we are trying to link this to the manufacturing cost that we are again simulating it with our internal simulation tool that allows us to have a full cost model from the wafer side up to the final packaged device. So I would say these three axes of analysis are highlighted in our performance product. And for example, for the silicon carbide discrete, we have already analyzed. In volume 1, we have covered the major players. So it was Wolfspeed, ROM, Infineon, STMicroelectronics. And also we are covering other players from Asia. So as an example, in the volume 1, we also analyzed Anbon Semi device, silicon carbide MOSFET. Of course, all the parameters I was mentioning from physical performance parameters are somehow compiled to facilitate a comprehensive analysis, to really show the impact of the performance, how they impact the cost, for example, on one side, and how they are really impact technology is impacting the performance itself. So I would say this comprehensive view from technology, performance, and cost is very valuable in these reports.
And I wonder, do you produce any recommendations therefore for applications, or as you say, with those three sort of parameters, you leave it up, people read the report and then they can therefore extrapolate which device best suits their application? Or do you, as I say, give any suggestion that, in this scenario, potentially this is the better solution to look at, or is that left up to the reader, shall we say?
Indeed, yeah, that's a very good question indeed, because that's, I would say, one of the major results or points that we try to highlight in some graphs we are providing. For example, of course, we are showing the different working conditions and testing conditions for the different devices, by comparing them under the same conditions, the same state. And this allows, in fact, to the reader of the report to see, for example, which range of temperature his targeted device is suited or it's performing the best. So we will provide all the information needed for the reader, and up to him to choose the best or the suitable device in the specific working conditions Of course, the highlights or the additional highlights we provide from performance and costs would give him more information and more details to fine-tune his choice regarding the cost and the technology parameters that somehow are not available on the public information or other products from other competitors, to have this complete view from technology, performance, and cost.
And I'm wondering, I mean, this is slightly sensitive, so I understand if you don't want to, but did you find in doing so, I mean, did you compare your results with, I don't know, not naming names, but some of the manufacturers' claims and I guess how were there sort of, shall we say, some differences between maybe what the manufacturers said their solutions were capable of, and when you tested them, perhaps it wasn't quite as a rosy picture, or was it fairly close, fairly closely aligned? I don't know if you were happy to answer that. Obviously, you don't need to mention any names. So.
I agree completely. I agree with you. It's a very, very, I would say, challenging point. And again, these hypotheses in the public data sheet, the public claims of the players and the manufacturers. So I would say for us, we take it differently, another way. So our approach is more, okay, we will define the same conditions, the same hypothesis for all the different players, regardless the different claims, because they are varying. Sometimes the claims are incomplete in some data sheets. So regardless all this public information, we will redefine and we retest all the devices under the same conditions that we are defining and detailing one by one in our reports. And on this very transparent and complete set of hypotheses and information for the reader, he will build his results. He will get to the full range of information he requires. So we will take it from this approach rather than starting from the public information, which I believe it's more consistent in this way, especially when comparing different devices. We really need to have this transparent, again, and third-party transparent, and compare them in the same conditions. Yeah.
And I'm wondering as well, longer term, I mean, for example, I do some work in the data center industry, and Gartner, the analysts are, they have their famous magic quadrant where they position people, within that. Do you have any plans, if you like, to come up with some kind of a sort of certification or hierarchy whereby you, if not badge different solutions, at least sort of indicate, where solutions sweet spots lie, etc., or will you continue to remain, if you like, strictly, here's the information, you, the reader, make up your own mind, if you like?
Indeed. So I would say, for sure, we are now intending to push forward, to really go further in our testing process, and to try, why not, to have some in situ application testing to really show how this device or how this choice of the design can fit or not some specific application. We're trying to build this kind of tests, and we are trying to develop indeed this product. We hope soon we can have something to show to the audience in this way.
And also, I'd ask, I mean, in terms of the manufacturers, I mean, did you approach them all and say, this is what we're planning to do? Do you want to sort of participate, or have you just acquired their devices and gone along with the testing, on your own, and then produced the results, or have you got some kind of buy-in's the wrong word, but I mean, as the industry welcomed what you're doing, I suppose, is the question.
Indeed. So as for now, since we are adapted this approach to be really a third party, to have this, I would say, this similar distance from all the players, we did not have, I would say, we had quite good feedbacks until now, because we are showing all the hypotheses of our test, of our performance test, that allows us to have this, I would say, objective point of view on the conclusions. So indeed, we acquired the different devices by ourselves, from the silicon carbide discretes and also the modules, in order to build the analysis. And of course, we have chosen them We showed the major technologies, the leading players on the market as well, but also with an opening to the new players in Asia, particularly in China, to have this, I would say, global view on the silicon carbide market. And of course, that's also what we are analyzing in our on other reports we are launching linked to the silicon carbide devices.
And in terms of the, I mean, I guess what we've been talking about applies to both. So the modules, yeah, the modules report, is that similar? Similar. You had those three parameters, which were what were guiding your, your test and analysis, or was it you doing anything different compared to the discrete, or was it a similar process?
Yeah, so I would say basically the methodology is the same, but in this case, of course, we are trying to compare the silicon carbide power module, leading edge, with focus on the automotive applications. So we got this power module like directly from the inverter of an EV. So it's I would say a power module adapted to the EV application. Of course, when we talk about modules, when we talk about EVs, we think about different challenges where managing the heat is crucial. Efficiency as well is very important to improve. So all these challenges linked to the performance of the power module, we are providing all the insights in the performance test report. So we launched the Semiconductors EM pack power module in the report, and I would say it provides valuable insights. For example, I can mention some metrics such as the threshold voltage evolution in terms of temperatures in comparison. And again, this is one, I would say, of the merits that we are comparing the silicon carbide power module with an IGBT power module. So by comparing these modules, how they perform, also how they cost, how they are manufactured, we have the industries, I would say, make smart choices or the best choices to build more reliable and efficient systems, making use of these power modules.
Okay, and I'm just wondering as well on the power module side, because I know you do a report, I think, on automotive power modules packaging comparison. So is there any overlap, or is that a sort of complementary report, if you like?
Indeed, yes, indeed. So, for example, in the automotive power module, we have analyzed the semiconductors object of the performance test, but with more details. So we go, it's more in tier down and so technology and cost report, where we are analyzing the full power module in our lab in tier down. To analyze the manufacturing process flow from the wafer side, so the dies inside the power module, up to the packaging of the power module. We are reverse costing this with our internal simulation tool, building the manufacturing process, and compare it also with other power modules, because the automotive power module comparison, as you say, is a comparative report with different power modules from automotive applications from different players. So we are choosing, we have analyzed the Infineon power module, latest generation from the hybrid pack generation 2 with silicon carbide MOSFETs, SiC 2 again, and also other power modules from, I can mention BYD power module, one important power module players as well in China. So we are comparing different power modules, also with IGBT power module from Semiconductors in the DCM, which is somehow quite leading edge package in the industry. So also we are including this power module in our comparison to really provide to the reader, I would say, the most complete information on the latest and the leading edge power modules on the market as for now, and give them the views about the design and how the design and the technologies of the power modules impact the manufacturing process flow and the cost, total cost of the power module.
Okay, and in terms of, I mean, the reports have been out for a little while now. So have you had any feedback from folks? You know, hopefully they found it useful. But any specific feedback you've had as to the reports and how helpful they've been to people? Because as you say, they're produced to help people make decisions. Is that actually borne out by the feedback you've been getting?
So we have some feedbacks up to now. Of course, maybe we need to wait for more time because some reports are quite recent. But as for now, the feedbacks we got are very positive in terms of, especially from device makers. Sometimes they are really they find that especially the hypothesis we are providing in terms of similar test conditions, for them it's very, very useful, and they cannot access this with the data sheet publicly available, unfortunately, when players may choose different test conditions and make the comparison of the performance somehow tough.
Yeah, so as you say, I mean, just to summarize, so the unbiased, the objective comparison is what, as you say, there's data sheets, they present information in different ways. They might omit certain information or enhance other sort of things, whereas you're sort of cutting through all that to produce something that's completely objective so that people can trust the end result. That's basically what you're doing. Is that right?
Exactly, exactly.
Okay, maybe just before we finish, I mean, I suspect you may have been asked this before, and it's a slightly open-ended question, I guess, but your thoughts. I mean, the power semiconductor market more generally, we've obviously got silicon, the sort of incumbent, we've got silicon carbide, and I mean, gallium nitride is making sort of significant sort of inroads as well. Just, I suppose, just your thoughts, if you can, as to how those three technologies, and if there are any others on the horizon, but how they sort of will coexist from your perspective for the foreseeable future, or how the market shares might change over time.
Yeah, indeed. Maybe in this context, one of the best reference I would say from the Yole Group products is more latest stages of the power module packaging industry. If we really focus on this market in terms of the different technologies regarding IGBT technologies versus silicon carbide, for example. So in our latest report, we have forecasted the IGBT XEV power module market to grow at 6% from 2019 up to 2029. On the other side, the silicon carbide power module will grow also at a CAGR of 23%, more than 23%. So I would say the BEV volume, so the battery electric vehicle we were talking about, would grow, making both these markets increase, of course, IGBT and silicon carbide, as of our understanding. And at the same time, the 800-volt platforms would show stronger growth rate, of course, mainly taken by silicon carbide. But I would say the majority of 800-volt models, so electric vehicle platforms, would integrate silicon carbide power modules. So basically, these are our forecasts in our latest reports from stages of power module packaging industry.
Okay, thanks for that. And fine, I suppose, taking the sort of real macro picture, in terms of just the sector in total, regardless of what materials are being used. Clearly we live in shall we say volatile times. But any thoughts? I mean, it's the power semiconductor and the various announcements around electric vehicles fairly recently said. Do you think that the power semiconductor, the momentum is there? Perhaps back to my first question, sustainability is still front and center, and therefore power consumption is very much a focus. Therefore, power semiconductors are going to stay or grow in importance, and therefore have a healthy future. I suppose that's the question.
So essentially, we hope that we believe the power electronics is the solution for a greener future. So this is a belief. So we hope that all the players, the device players, system players, would have all their contribution to really succeed and have these targets that we all aim to have this greener future and with different industry players, I would say.
Okay, I think that's covered the questions I had, and it's been fantastic to chat to you and for you to share your insights on the reports. Obviously, folks recommended to go and look at those reports. I think we had an article in the last edition of our magazine, but there's plenty of information in the reports themselves. But at least for now, I mean, really appreciate the time you've given me. Thank you very much. Thank you.
Thanks a lot, Philip. Thank you.